All right, so our next adventure using the Pythagorean theorem is to start seeing this Pythagorean theorem in some three-dimensional shapes. So yesterday with our word problems, we started seeing them in more real-life situations, but another way to see them is that it's not just always a single triangle, but a triangle that's part of a bigger three-dimensional shape or a bigger shape in general, right? So remember, in order to use the Pythagorean theorem, we have to have a right triangle. So the first test is to start training your brain to see triangles. And then after that, to really double check and make sure that these are right triangles before we can start plopping in the Pythagorean theorem, right? So if you look at this shape, and this could be, definitely something you draw if you have, like if you're in class, you probably have copied notes, but otherwise, give it your best shot to draw that in 3 dimensions. But if we're looking at this shape, the first thing we need to do is just see if you can find some triangles, right? So hopefully, as you're looking at it, you're noticing that I have a triangle down here, right? Down here at the bottom, there's a triangle. And then maybe you're noticing as well that I have a triangle here, kind of slicing through the middle of the shape. Right? Now, I have some right angles marked in this picture, so we do know that both of those triangles are right triangles, so they should be able to be used with the Pythagorean theorem, right? Now, the other thing is, if we didn't know that those were right angles, or if they weren't marked in the picture, we could read a little bit more carefully, because this says that this is a rectangular prism, and we know that the corners, all of the sides are form right angles in a rectangle, and that these are all rectangles if this is a rectangular prism. So I do know that I have right angles. So if I read now in my problem, it says, find the measure of segment EO. So I'm trying to find segment EO. Now segment just means it has 2 ends, and when it says segment EO, it means that it has ends at E and point O. So hopefully you are understanding, and hopefully this is review for you, but the segment we're trying to find is this one right here. This is what we're trying to get to. That's our goal, right? Is to figure out how long that segment is. Now, if I look at that green triangle that we noticed, that's the triangle that this segment EO is a part of, right? Do I have enough information right now to use the Pythagorean theorem in the green triangle? I have a side length of 12, but that's it. I don't know this other side length down here in order to be able to figure out, right, use my Pythagorean theorem. I'm missing this spot right here. I need that segment so that I can do my a squared plus b squared equals c squared. Ooh, now, are you noticing the yellow triangle? Do I have enough information to prove or to use the Pythagorean theorem on the yellow triangle? Yes, I do, because I do have 2 side lengths, so I could start with this yellow triangle down here because I have enough information. Then I can use my answer from this yellow triangle as part of my green one. So I'm going to start by finding this segment OY, or the one that I marked with a Y. That's what I'm going to start with. So hopefully you remember from the last few days the Pythagorean theorem, right? A squared plus b squared equals c squared. I'm noticing my right angle, and that segment I'm trying to find, y, is across from the right angle, so that's going to be my hypotenuse. So my first equation will be 3 squared plus 4 squared equals y squared. And then hopefully you can do this really quickly, or at least you know what you're doing, so you can always pause your video and pick it up later. But 3 squared is 9, 4 squared is 16 equals y squared. 9 plus 16 is 25. And then I'm going to square root both sides. So I get y equals 5. 5 equals y. Same idea, right? So here I now have a 5. That's kind of confusing, but this side length that I was trying to find is 5, so I just figured that out. So now I have enough that I can now do my green triangle with the 12 and the 5 and trying to solve for x, which is the one that I wanted all along, right? So again, if I'm looking in this one, I'm noticing that my right angle is here, so the side that I'm trying to find, that x, is my hypotenuse. So when I write my equation, that will be c. So I could have 5 squared plus 12 squared equals x squared. And again, hopefully once you get to this point, things are feeling pretty good. So I have 25 plus 144 equals x squared. And then after that, I get 169 equals x squared. And I take the square root. And I get x equals 13. And that was the segment I was trying to find, right? I was trying to find segment EO, so I can say segment EO equals 13. So the big idea here in our three-dimensional space, find those triangles, make sure they're right triangles, see if you have enough information. You might have to start with a different one before you can get to the one you want. All right, so here's another example just to kind of wrap your brain around. If you're feeling confident, go ahead and pause your video and see if you can do it on your own. What is the longest flagpole that can be shipped in a rectangular box that measures 4 feet by 4 feet by 12 feet? Round to the nearest hundredth when necessary. So if I'm picturing this box, the longest flagpole that could fit would be going at this diagonal through the whole box, right? That's going to be a longer segment. That R, right, that's the one that's labeled R, is longer than the one that's labeled S. This one down here is definitely shorter because it's laying flat down at the bottom. And if I angle it up to the top, top corner to bottom corner, it's going to be a longer one. So I'm trying to find R. So again, hopefully as you're looking at this, we're starting to see some triangles. Do you see this blue triangle down at the bottom? And then, are you seeing this green triangle kind of propped up here? All right. Now, before we can use any Pythagorean theorem, we got to make sure that these are right angles. There's nothing marked in the picture this time. Oh, but it does say rectangular box. And all of my corners make right angles in a rectangle. So that does mean that I have a right angle down here. And it does mean that it's standing straight up and down, so I have a right angle there as well. So I do have right triangles, so Pythagorean theorem should be good to go. So let's check out this blue triangle. We see that I have a 12 on this side, right? What about this side, though? Oh, well, I see that this side is marked as a 4, so that 4 must also go over here. Aha! So I do have enough to start with to solve for S because I have 2 sides, so I can solve for the third. If I'm looking at my green triangle, oh, I do know this segment because that's the same as this one over here, and that's marked as 4. So the height of it would be 4, but I don't have anything else. So it's looking like I'm going to have to start with the blue triangle. So again, I'm noticing that my right angle is here, so that side S that I'm going to start by finding is across from the right angle, so that's my C. So I'll have 4 squared plus 12 squared equals S squared. Okay, so that's 16 plus 144 equals S squared. And 16 plus 144 is 160. Oh, now this is something new. We have not encountered this yet. And this is that I need to take the square root, and 160 is not a perfect square, right? So I have S equals the square root of 160. Now in this chapter, in this unit, we've been really focusing on simplifying radicals, right? However, be careful here. It says round to the nearest hundredth when necessary. So I'm not going to have to simplify my radical because I'm going to end up rounding in the end, right? So I don't need simplified radicals if they're okay with me rounding. However, if I round right now, I'm going to have to plug that number in and do a whole Pythagorean theorem afterwards. And every operation I do after I round something gets farther and farther away from the correct answer. So I definitely do not want to round right now. Do not round or simplify until the very end. It's just wasted time, and don't round because you'll get the wrong answer. So do not round or simplify until the very end. So I'm just going to leave this as the square root of 160. It's also going to help us in another way, but I'll let you see that. Oh, we can't even see that. Sorry. Okay. So square root of 160 is going right here, right? And we'll see how this is going to help us. But I do now know that that's 100 square root of 160, and I have the 4. So now I'm ready to go ahead and start working on my green triangle. So again, the right angle, that R that I'm trying to find is across from the right angle, so that'll be my C. So I'll have 4 squared plus square root of 160 squared equals R squared, right? Use those parentheses. All right. Now, 4 squared is 16. oops, square root of 160 squared, well, the square root and the squared just cancel out, and I just get 160. So leaving it without simplified or anything like that actually saves me a whole bunch of time because I'm just going to end up getting rid of the square root anyways. So that's what I recommend. Don't simplify or round till the very end. Well, let's see. 16 plus 160 gives me 176. And then I do have to take the square root of 176 to get r. And now let's see, r equals the square root of 176. That's not a perfect square. So at this point then, we're typing into our calculators, right? We don't have to simplify it first because I'm just going to round it. So I'm going to type into my calculator the square root symbol, 176. And so when you type that in, you should be getting 13.2664, et cetera, et cetera, et cetera, right? Now this says that I want to round to the nearest hundredth. Hundredth is 2 decimal places. So I want to have 2 decimal places when I'm finished. So this first 6 is going to look at the next one. Whoa. And it's going to say, should I stay as a 6 or should I round up to a 7? Since this is 5 or above, it's going to round up. So r equals 13.27. And I'm going to look back. We are talking about feet. So it's 13.27 feet. So again, remember, look for those triangles. Make sure they're right triangles before you do Pythagorean theorem. Start with the one that you have enough information and work your way through. All right, here's our last one we're going to do together. Hopefully you're feeling pretty confident. See what you can do here. So this one says find the measure of D. So this is our segment slicing through the middle here, right? This is the one we're trying to find. Given that the shape is a cube with side lengths of 6 inches on each edge. Round your answer to the nearest tenth when necessary. All right, so a cube means that all the sides are exact same length, right? And it says that each of those is 6 inches. So this is 6, this is 6, this is 6, right? Now in this one, we don't have our triangles drawn for you. So this is really your test to see, do you know where to draw that line in to create those triangles that we've been seeing in the other shapes. Now, 3-dimensional shapes are kind of hard to picture. Every time you look at it, it looks kind of weird. You blink and it looks different, right? But if you look back at our past pictures, we're really trying to make these triangles that look like this, right? I want to connect the bottom of that green segment to the other corner so that I can get these 2 triangles, right? Are you seeing now I have this blue triangle here and I have this green triangle here. And so by drawing in that segment, draw in, if you need to, this black segment here, then I'm making those triangles. Now again, when I have a cube, all of my faces are squares, right? Which means that all these corners make right angles. So I do have right angles all here again. Make sure you put those in your picture. So hopefully you're getting the idea here. The blue triangle is going to be the one that I can solve for first. So my first one, I have sides of 6, the side across from the right angle. Let's call this x, okay? That's the one I can start with. That's going to be my hypotenuse. So I have 6 squared plus 6 squared equals x squared. So I have 36 plus 36 equals x squared. And then I have 72 equals x squared. I take the square root of both sides. And 72 is not a perfect square, but again, like we talked about, I don't want to waste my time simplifying right now because I'm going to just be rounding at the end. I'm rounding to the nearest tenth, and I definitely do not want to round here because then my answer will be really far from the correct answer. So x equals the square root of 72, and that's how we're just going to leave it. But now I have enough to do my second triangle, my green triangle. And again, on this one, D, the segment I'm trying to solve for, is across from the right angle. So that's going to be my C. So I have 6 squared plus radical 72 squared. Whoops, sorry, not 22, 72 equals D squared. I get 36 plus radical 72 and squared cancel out, so I get 72 equals D squared. 36 plus 72 is 108. And then I'm going to take the square root of both sides. All right, and 108 is not a perfect square, so again, I have to round to the nearest tenth this time when necessary. So I'm typing in square root of 108 into my calculator, and I'm getting 10.3923, etc., etc., etc. Tenth is one decimal place, right? So I want to keep one decimal place in my answer. So the 3 is going to look at that 9, says, oh, yes, please, round up. So it'll be 10.4. Looking for units. Ooh, looks like we're talking about inches, right? So I have 10.4 inches is how long D is. All right, hopefully after those practice problems, you are feeling confident in solving with the Pythagorean theorem in three-dimensional space, and you can go ahead and practice.